In this video, we will talk about a very important concept called as TDD or test driven development. Now, many developers have different views about TDD and its usefulness. Now, apart from those views, let's not get complicated in the first step itself. Many people are confused about what exactly is TDD. So in this video, we'll first try to understand what is TDD. We will see a simple demonstration, and finally we will talk about the advantages of TDD. Now, the most important point to remember is TDD is not a technology. It's an approach. It's a thought process of thinking testing from a different perspective. Okay, so what do I mean? Now, in a normal development scenario, what you do is that you first write the code and then you write the test case. But in TDD, you first write the test case before even you write a single line of code. And then you write the code, which will run against that test case. In other words, the process is something like this. You can see on your video. First, you write the test case. Before even you go and code your component, you first write the test case, execute it, and it will fail. Okay. Then you write enough code so that it will pass. Okay. After that, you refactor it. Must be you add some more methods or you do something. Again, run the test case. Again, ensure everything is working. So in other words, basically you first write the test case, it will fail. Then you pass the test case by writing some code to it. Then you refactor, until you finish your coding. So let's see a simple example of how to actually do TDD. So let's assume that we want to create a maths component, which has add and subtract functions. So before even we go ahead and we start coding this maths component, as per TDD, we have to first go and write the test case. So I'm going to use VSTS unit test project here. So I'm going to go, and you can see that I have selected the new project. I have clicked on this test menu here, and let's go ahead and first write the test case saying maths test project. So as per TDD, the first thing is you'll not go and write a single line of code, but you'll first go and write the test case. So that's my test project created. Now, as we said that, this maths component is going to have two methods. One is to do addition and the other one is to do subtraction. Okay. So let's go ahead and write a test case which will do test add. This test case will go and test the add function of our maths component. Okay. So we'll say here maths component obj is equal to new maths component. See, now one important point to remember here is that I have yet not created the maths component. I have yet not written a single line of code. But what I'm first doing is I'm going and writing the test case. Okay. So that's why you can see that there are lots of red signs here, and that is fine, because we have yet not created the maths component. So I'll say here int result. So this maths component will have an add function. So I will pass him 10 and 10, and I expect assert.r equal, this, I expect, value as 20 here, because 10 plus 10 is 20, and the result is this one, right? So you can see that basically I have first gone ahead and I have written the test case. I have not yet written any line of code here, and I am now clear that what I'm expecting from my add function or from the maths component. So we have completed the first step. We have first written the test case, and now let's go ahead and compile this project. So let me go and build the solution here. Now definitely this project will not compile, right? But that's what is important. So what it indicates now is that, okay, this test case has failed, you can see, and it's saying that basically there is no maths component created. Okay. So now the next step is we have to go and create the maths component. So let's go ahead and add a new project called as a maths component. So let's go ahead and create a library here called as maths component. So there's our class library. So the first thing is, let's go ahead and rename this class as maths component. I can see that I'm calling for troubles here because the maths namespace as well the maths component is the class name is same. So let me go and rename this to maths namespace, so that we don't end up into any kind of problems. Now the first thing is we have to go and create a function called as add, which will actually take two numbers here. So int num1 and comma int num2. So now what I'll do is I'm not going to write any code still. Okay, I'm just going to write saying return 0. In other words, I'm writing least amount of code so that at least that maths test project compiles. So my intention here is to not start writing actual logic, but to just write enough thing so that the class test project at least compiles. Okay, so let me go and reference this the maths component in the maths test project. So I've done that, and let's go ahead and import the maths component namespace, and you can see that everything is fine here, right? So now if I build my project, everything should compile, including the test project. So what we did first, as per TDD, we did not write a single line of code, but we went ahead and we created the test case. We then built the test case. It failed. The build failed. Why? Because definitely the component was not created. Then in the next step, we went ahead and we created the component, but we created minimal code, so that at least we can go and compile a test project. Okay, and you can see that it is now done. Right, now let me go and run this test case here. I'm going to go and run my test case here. So test view, and I'm going to go and say run this test case. Now if I go and run the test case, right, obviously it will fail because there is no logic written still in the add function, and the add function is returning 0 while I'm expecting 20. Okay, so now I would like to go and refactor my adds function to at least add function with some logic. Okay, so I'm going to go here and say, okay, let me put some code here, num1 plus num2. Great. And now let me go and build the project. So there the project is built, done. Now let me go and run my test. So definitely the test case should pass because I've written the logic, and the logic is now returning me 20, and the test case is expecting 20. So everything fine. Now the next thing is we would like to go and also implement the subtract function. Again, the same thought process. Do not go and write first the subtract function, but first go and write the test case. So we'll do a control C here, we'll do a control V here. Let me just take this up. So we're going to say here test subtract. Again the same thing, I'm going to say maths component obj equal to new maths component, and I'm going to say obj dot, I'm going to say first int result is equal to obj dot subtract 10 comma 10, let's say. And what I expect here is assert dot r equal, I expect value 0, and let's compare it with actuals. Right, now again you can see that there is a red sign here because definitely there is no subtract function, and that is fine. So I'm going to go and build this, and it shows me saying that the subtract function is not implemented. So our test case has failed. So now the developer has to go and implement a subtract function. So he goes back here, he goes back to his maths component, and he says, okay, I'm going to put here public int subtract int num1 comma int num2, and I'm going to say 0 so that at least minimally the code compiles. I will build this. Now even the subtract thing is not showing me errors. Now let me go and run my test case again. So I'm going to say test view and say yes, let's go and run both the test cases. So If I run them, okay, now there's okay, now you can see over here, basically both the test cases have passed. Why? Because in the subtract, right, I have given equal numbers, and 10 minus 10 is 0, and here here I have written hard-coded 0, so that's why the test case has passed. So let me just go and say here, okay, how about 10 and 9? So that should give me 1. Okay, so let me go and again build my solution here just to ensure that things are proper. And now let me go to test windows, test view, and say, now let me go and say again run the selection. So now you can see that, okay, at least the compiling is now done, but I can see that the test subtract has failed because he's saying that I'm expecting 1 and he's actually returning me 0. Okay, so now again the developer goes to the class and implements the subtract function. So it says num1 minus num2, right? So again you go and now run the test case. So again you say right click, run the selection. Okay, so you can see that how iterative the process is. You first write the test case, then you write the code, then you run the test case. If it is failed, again you go and refactor the code, again come back and write new test cases. So in TDD, the most important part is you first write the test case and then you go and write the code. Now you must be wondering, what is the advantage of TDD? What is the advantage of writing a test case first? Must be that some of the developers are amused by saying that, oh my god, I have to write first a test case and then the code. Isn't it time consuming? And how does it add value? The first important value add here is, at least I think personally, is that it makes your intention clear. It changes your thought process. Just think, if I would have said that, okay, go ahead and write your maths component, must be you would have gone ahead and written it. But with this approach, what happened here is that you first knew what you wanted, okay, and then you went ahead and you wrote your code. So with this approach, what's happening is your requirements are getting clear, your intentions are getting clear. So the first advantage is that your intentions are clear. You understand the requirement very well. Okay, so that's the first advantage of TDD. The second big advantage of TDD is iterative development and testing. Now whenever we talk about software projects, they evolve. Okay, means software projects don't happen overnight, right? I'm sure that people who have worked with bigger projects, they would buy my point that they don't just come from the air. They evolve. With every code they evolve, right? So here you saw in the maths project also, how the code was evolving, and by every code I was writing, I was ensuring that I was running a test case. And with this approach, what happens is you have more confidence on the software. You know that you are creating a good software, right? So the second big advantage of TDD is iterative development and testing. Okay, so second point here is iterative development and testing. The third important point about TDD is you catch defects in the early stages. Now I'm sure that everybody understands here what is the importance of catching a defect on the early stages. If you, let's say, I'm just giving example. If let's say that if there is a defect injected in the requirement phase, for one defect injected in the requirement phase, there will be 10 defects in the development phase. For one defect which is injected in the technical design document, there will be at least 5 defects in the coding phase. So in other words, the earlier you catch the defect, the better it is for the project. Now here, by writing the test case in the early stages itself, you are ensuring that you are ensuring that basically you can catch the defects on the early stage itself. Okay, so the third important advantage of using TDD is catching defects early. The fourth advantage of TDD is that you are forced to write the test case, or you are forced to write unit test cases. Now what happens is, let's say that if you do not use the TDD approach, what you will do is probably you'll go and create the maths project, you'll go and write your add and subtract function, you will execute the project and you'll probably go live, and you'll never ever think about even writing unit test cases, right? But here, with this approach, you're forced to write the test cases, which is again very good for you, right? So you are forced to write test cases. Okay. The fifth advantage is that your code starts getting documented. For example, here I can, when I look at this test subtract here, I can understand that how I can use the subtract function. So that is a kind of a self documentation starts evolving by these test cases. So I can say documentation, right? So these are some of the advantages of TDD. First one is that it makes your intention clear. Okay, you understand your requirement well, and with that understanding, you have better interfaces created. Second, the development is more iterative, with testing. So in other words, your code evolves, and with every evolution, you actually test the code. You catch your defects early. Third point, you catch your defects early. Fourth point, you are forced to write test cases, which is good. And finally, there is a kind of a self documentation, which evolves, when you use TDD. So these are like, 5 important advantages, which you get, when you use TDD. So just summarizing, TDD is not a technology, TDD is not a tool, but it's a thought process. It's a thought process, where you write your test cases first, before even you go and write your code. And many of the people also call it as a red-green refactor process. In other words, you first write the test case, so everything fails, so it's red. Then you go and put some enough code over there, so it passes. And then afterwards you go and refactor it, and you keep on running your test case until your project finishes. So it's also called as, the red-green refactor process. Okay. So I hope that you enjoyed this video. In this video, we were trying to understand what exactly is TDD. We saw a small sample of a maths project, how actually TDD evolves and tests your project. And then we finally talked about, some advantages of TDD. So I hope that you enjoyed this video. Keep seeing this testing section for more testing fundamentals. Thank you very much.